Okay guys, now we're going to look at projectile motion, and we're going to be able to calculate distance, time, velocity, and those kind of things for projectile motion. Now for this one, at the very beginning we're going to just look at a horizontal launch. So no angle, just a horizontal launch. So our definition for projectile motion: any object that is thrown or launched and experiences a constant gravitational force. So again, if we're going to do a horizontal launch, our tennis ball, if you will, okay, will experience projectile motion. Again, the only force acting on this object after it is launched is gravity. So that will be projectile motion. So once it leaves your hand, the object is under constant gravitational force. That'll generate a curved path, and that is due to the gravitational force. So that is projectile motion. So no rockets. Okay, once you throw the tennis ball, gravity takes over and inertia. So we did a little experiment with this where we rolled the tennis ball and had it fall, and then we dropped the tennis ball simultaneously. Okay, and as you notice, they will both hit at the same time. Both tennis balls experience a constant acceleration of negative 9.8 meters per second squared. And notice even the one that is launched horizontal. See if you look up here, horizontal. Okay, so the yellow tennis ball is still falling with a constant negative 9.8 acceleration, as is the one that is dropped straight down. Okay, so projectile motion is free fall with an initial horizontal velocity. In this case, we're shooting it horizontally. All right, so a couple important points here. Horizontal and vertical motions don't affect each other. They don't affect each other. So even though I throw it horizontally, it does not affect what is happening in the y direction. Okay, horizontal does not affect vertical. X does not affect y. Remember, we have two vectors. We have an x and a y. And if you add those two together, you get a resultant, of course. Okay, but the x does not affect the y. They're independent. Okay, x and y are independent of each other. Okay, when you add them together, x and y, you get the resultant. Okay, but x does not affect y, y does not affect x. They are independent from each other. Horizontal, constant velocity, no acceleration. Acceleration is 0. The vertical, the y, we are in free fall, and of course we have our acceleration due to gravity, negative 9.8 meters per second squared. And we're going to do all kinds of applications, knowing when a bullet hits the ground, knowing how far you threw the tennis ball, how far did the football go, how tall is a cliff. We can figure out all these things using these equations. The shape of our projectile motion, of course, will be a parabola. And of course, there's a whole equation with the parabolas that you learn about in math class. If you took higher level physics, then you could apply that to your projectile motion. Some other points, again, horizontal and vertical motions don't affect each other. Okay, x and y are independent of each other. Projectile motion can be understood as a horizontal motion and a vertical motion analyzed separately, or two vectors added together to create a resultant. We'll look at the formulas, of course, here in a second. One thing I do want to point out is projectile velocity is minimum at the top. Remember, if you throw something up in the air, okay, so even our parabola, okay, velocity in the y direction is going to be 0 at the top. All right, so this slide right here, this information, if you will, is going to be super important. Super important. So we're going to launch something. Let's just say a tennis ball. It's going to go up and down, right? So here's our projectile motion. Okay, and if you understand the information here, I feel like you probably have a pretty good grasp of, just conceptually what's happening. And then, of course, we're going to practice our calculations. Okay. So since we have a parabola here, we have an x component and we have a y component, right? I want to look at the x component first. Okay, so let's look at x. Let's say my initial velocity in the x direction, I'm just going to make up a number, 5 meters per second. Okay, and we just want to look at several different points here. Okay, we want to label the velocity at every point. Okay, so in the x direction, there is no acceleration. Okay, gravity only acts in the y direction. There is no acceleration in the x direction. So I know my velocity in the x direction here is going to be 5 meters per second. Well, what about at the very top? Velocity in the x direction is 5 meters per second. Well, what about over here? Do you see a pattern developing? 5 meters per second. What about right before it hits the ground? 5 meters per second. So velocity in the x direction, by the laws of physics, okay, there's nothing affecting the x direction. Gravity only works in the y direction. Therefore, the velocity will be constant in the x direction. So, what's our acceleration in the x direction? Well, if your velocity is constant, acceleration in the x direction has to be 0. So our x vector will be a constant velocity, therefore there is no acceleration. There is no acceleration. Let's look at the y direction. Again, I'm just making up a number here, but velocity in the y direction, we'll just say 10 meters per second. Again, just made up a number. Eventually you'll be able to calculate that number, but right now, just for argument's sake, I made up 10 meters per second. So now, well, what's our velocity in the y direction here? Well, I can calculate it, but I just know that it will be less than 10. Do you know why it will be less than 10? Well, hopefully you'll figure that out here in a second. At the very top, in the y direction, okay, your velocity is 0. Your velocity is 0. Okay. What about over here? Velocity in the y direction will be -6, let's say. Again, we could calculate it, but it's more about the conceptual understanding of it. Over here, right before it hits the ground, velocity in the y direction will be -10 meters per second as I run out of room here. So notice we went from 10 to 6 to 0 to -6 to -10. There's probably a pattern in there. Perhaps you've learned enough physics now that you can explain what is happening there. Well, what about acceleration in the y direction? Well, what force is acting in our y direction? Very good. Gravity, negative 9.8 meters per second squared. What about at our second point? Negative 9.8 meters per second squared. What about at the very tippy top? Negative 9.8 meters per second squared. What about over here? The acceleration in the y direction, negative 9.8 meters per second squared. And right before it hits the ground, negative 9.8 meters per second squared. So, nothing affects in the x direction, therefore you have constant velocity. In the y direction, negative 9.8 meters per second squared is your acceleration all along the path. All along the path. That, of course, will affect your velocity. That will affect the velocity. Well, let me know if you have any questions on this. This will be something I would expect you to learn and be on a quiz in the near future. So now let's look at some math, shall we? All right, so here's our equations. There are two sets. One for horizontal and two for the vertical. So one for the x vector and a second set of equations for the y vector. Now, I'm going to rewrite these equations because I've lost my subscripts when I transferred this over to the video. So, the x distance is your velocity in the x direction times time. That should make sense. Acceleration is 0. So there's no acceleration in this equation. It's just simply distance equals velocity times time. Or, if it makes you feel better, velocity in the x direction is distance divided by time. Again, if you have no acceleration, you can use this equation for velocity. Now, our y vector or vertical equations, again, I'm just going to write it a little bit differently. Velocity in the y direction final equals acceleration times time. Okay. Velocity in the y direction final squared equals 2 times the acceleration times your height. Okay, y will be height. And then our last equation, the height is 1/2 acceleration time squared. Hopefully that equation looks, all these should look a little bit familiar, hopefully. Of course, in the vertical direction, A, you know it, 9.8 meters per second squared. Okay, now these equations work for a couple reasons, because we are launching in the horizontal direction, which means our angle is 0. Okay, we're going to launch horizontally off the cliff or throw the baseball horizontal to the ground. And we're also assuming that our initial velocity in the y direction is 0 as well. So after we practice these equations, we will come back and change the angle and the starting velocity in the y direction. Okay, but we'll practice these first and get a good background and baseline, and then hopefully we can make it a little more complicated next week and everything. So let's look at a couple sample problems. All right, so in this problem, list what you know and, of course, what you're trying to solve for. A Winchester .22 bullet is fired horizontally with a muzzle velocity of 225 meters per second. The gun is held 1.4 meters above the ground. How long does it take the bullet to hit the ground? How far does the bullet travel horizontally? All right, so I would draw the picture, of course, as best I can. I know the rifle is 1.4 meters above the ground. I know the velocity coming out is 225 meters per second. Okay, so this tells me that Vx is 225 meters per second. Notice that's horizontal x direction. I know my height is 1.4 meters. And as always, A is negative 9.8 meters per second squared. And that reminds me, my height, since the bullet is falling down, it's probably negative 1.4 meters. How long does it take to hit the ground? So that tells me I am solving for time. And how far does the bullet travel horizontally? That would be x. So looking back at the equations, pause the video and look back if you need to. I would probably use y equals 1/2 at squared to find the time. So negative 1.4 equals 1/2 negative 9.8 time squared. So negative 1.4 equals negative 4.9 t squared. 1.4 divided by 4.9, because I can lose the negative, is 0.286. Take the square root of that. So, let's see, I got to find the square root button here. Oh, there it is. 0.286 is 0.53. So notice I gave you the answer, of course, just to help you, but you can always check your work there. 0.53. Now, I also want to find x. Well, I know that x equals velocity in the x direction times time. So x is 225. Time I just calculated of 0.53. So 225 times 0.53. Get 119.25 meters. So that checks out. Look at question 2. You and a friend are pondering the physics of projectile motion. You are on top of a 20-meter tall building. Again, draw the situation. I think that will help with a water balloon. How fast do you have to throw the ball to peg your other friend who is standing 12 meters from the base? Okay. So I know y is negative 20, because again the water balloon is going to fall down. I know x is 12. Okay, I know A is negative 9.8 as always here on planet Earth. So what am I solving for? How fast do I have to throw it? So Vx. Well, if I look at my equation for velocity, okay, I know it's distance divided by time in the x direction. So I'm missing time. Well, if I use this equation, 1/2 at squared, I can solve for time and then plug it into the second equation to find my velocity in the x direction. So y is negative 20, 1/2 negative 9.8 t squared. So due to space, I'm just going to say t squared is 4.08. Take the square root of that, and I get t is 2.01 seconds. So now I'm going to take that answer, put it right over here. So we know it's 12 meters divided by 2.01, and so I need to throw the water balloon basically with 5.97 meters per second, so almost 6 meters per second. All right, I'm not going to do these two problems. There's the answer to number 3, and then number 4, of course, you can try on your own as well, and that's what we'll do in class is try some of these problems on our own. All right, so hopefully this video will help, and please let me know if you have any questions. We're going to spend several days on this. Talk to you later.